Good morning, everyone. Today, me and my group member, Rifa and Ibrahim, will present our OPC Group Assignment 2 Forecasting and Least Square Method. First, what is forecasting? Forecasting is a process of using historical data and information to speculate about future situations. It is a tool to help make future decisions. In the forecasting process, possible future changes are usually influenced by identified trends and patterns in historical data. Next, what is least square method? Least square method is a mathematical technique widely used in statistics and data analysis for finding the best fit line for the set of data points. This method minimizes the sum of the square difference between the observed value and the value predicted by the model. This reduces the overall error in the prediction, making the model prediction as accurate as possible. For example, we have 4 data points and using this method arrive at the right side graph. Look at this graph. The straight line shows the potential relationship between the independent variable and the dependent variable. The goal of least square method is to reduce this difference between the observed response and the response predicted by the regression line. Less residual means that the model fits better. The data point needs to be minimized by the method of reducing residual of each point from the line. Next, let's look at the least square method formula. Y equal to mx plus b. Y is the dependent variable, x is the independent variable, m is slope of the line, and b is the y-intercept. How to calculate the m? M equal to m times sum of the xy minus sum of x times sum of y over m times sum of the x squared minus square of the sum of x. After that, how to calculate the b? B equal to sum of y minus m times sum of x over n. N is the number of data points. Next is application of least square in forecasting. In business, identify sales trend to guide inventory and budgeting decisions. Using the least square method, help business forecast demand and adjust resources effectively. Companies often use historical sales data to predict future demand. By applying the least square method, business can fit a trend line to their sales data, capturing the overall picture of sales growth or decline over time. This trend line helps smooth out random fluctuation, so forecasts are more accurate. In economics, government and financial situation use this square method to forecast economic indicators such as GDP growth, inflation, and unemployment. This square method in economic forecasting provides a reliable basis for policy decisions that affect national and global markets. It enables economies to identify meaningful trends in noisy data, enabling proactive planning and response. If the forecasting GDP shows slow growth, the government may introduce stimulus measures to boost the economy. Similarly, if inflation is expected to rise steadily, policymakers may consider tightening monetary policy to prevent overheating. Least square method in engineering field can use to predict various factors such as component reliability and energy demand, which are critical to system design and maintenance. Future energy demand can be predicted by fitting trend line to past energy consumption data. For example, engineers can analyze the wear of components over time and use this square to predict when a part is likely to fail. This prediction allows for preventive maintenance, reduce downtime, and costs associated with unexpected failure.
What are the steps to implement the least squares method? The least squares method is used to minimize the differences between observed data points and the values predicted by our trend line. The steps are straightforward. First, we collect and define the variables we want to analyze. This could be time and sales data or any other related matrix, for example. And next, we calculate the slope which represented as B, and the intercept as A, which together form the equation of our line. And finally, we graph our data by drawing the best fit line to represent the trend visually. This line helps us make informed prediction about future values. And there are several assumptions underlie the effectiveness of the least squares method. We assume there is linear relationship between the variables, meaning that one variable consistently affects the other. The method also works best with minimal outliers and stable data. Too many random variations can skew the results. Finally, this method assumes that historical trends will generally continue into the future, making it less effective when unexpected changes occur. The limitations and when it may not work well. This method has limitations. For example, it doesn't perform well with volatile data, where there are frequent unpredictable changes, or in data sets with nonlinear trends. When outliers or random fluctuations are significant, they distort the accuracy of the trend line. In such cases, alternative methods like moving average or exponential smoothing may offer better accuracy as they account for more recent data points or adjust dynamically to change. Comparison with other forecasting methods. So, in comparison to other forecasting methods, the least squares method treats all data points equally, which is an advantage in stable datasets, but a disadvantage when recent data is more relevant, unlike methods that weigh recent data more heavily. This method is designed for long-term trend analysis, making it ideal for scenarios where a gradual and constant trend is expected over time. So, when to use least squares method? The least squares method is more effective in specific situations. It works well when predicting trends in data that shows a steady and linear pattern. It is especially suited for long-term forecasting also. The method is ideal when working with minimal random fluctuations, allowing us to achieve accurate predictions based on historical patterns. So here an example about how to apply the least squares method. Imagine you manage a small store and want to project future sales based on past trends. Here's a scenario where you have 7 months of historical sales data. The first step is to collect and define your variables. Here, the months serve as your independent variable, while the sales figures represent the dependent variable. Next, we calculate the slope and the intercept of our data. This allows us to create a predictive equation where we can estimate the future sales. Finally, we graph the data and draw a best fit line through our points. This line visually represents the trend, helping us anticipate what sales may look like in upcoming month. By using these three steps, we can effectively forecast and plan for the future.
Assalamu alaikum, myself Rifat Afroj Orpi. My metric norm is MEM241005. Today I'm going to cover the advantages, disadvantages, future scope and the conclusion part about the least square method. Least square method comes with several advantages, particularly in terms of simplicity and effectiveness. It is popular for its simplicity and is easy to accessible for all levels of data expertise, and its effectiveness is also very good, which gives accurate forecasting results, and it is ideal for trend identification. Also, it can minimize overall error and gives an optimal fit, and its versatility is also very appreciable. It can be used both in linear and non-linear models, and it gives quick analysis and real-time ready data. Though it has several advantages, but it comes with some disadvantages also. Here are the most popular disadvantages, which are sensitivity to outliners, like large error from outliners can distort trend sometimes, then assumes linearity. It can sometimes give a defective data for complex or non-linear models. Then the risk of overlifting in fits noise instead of trends is very high. Then it sometimes assumes equal spread, and it can give limited robustness to sensitivity to multicollinearity, like high correlation between predictors can cause instability. Then sometimes data quality dependency, it gives some errors. So these are the industries where least square forecasting method is commonly applied, like in finance and economics, then in manufacturing and environment, in inventory management. Forecasting demand to optimize inventory and production schedules, reducing waste in the schedules, and improving the overall supply chain efficiency. Least square method can be used. Then in healthcare and medicine, then energy and utilities, meteorology and environmental science for weather data prediction, least square methods can be used. Then in sales and marketing, analyzing customer and market trends, aiding budget allocation, it can help a lot. Then the future advancements and hybrid method involving least square methods. These are the scopes where least square method can be involved. In machine learning integration, least square method can be used. In hybrid model because hybrid model can identify any patterns which least square method might alone can be missed. Then in regularization techniques, it can be used. Then in time series forecasting data prediction, where ARMA models and ARIMA models for dynamic forecasting useful in industries where seasonality trends are popular. Then big data applications, there in least square method can be used. Then in automation and real-time forecasting, least square method can be used for real-time forecasting, especially valuable sectors. Then in conclusion, we can see that least square method is reliable and it's widely used, and it is popular for its simple and effective nature, and it can involve in newer technologies and complex data needs. So it is very effective method, we can say. Thank you. Would you like to any further details of these topics? You can let us know in the comment box. Thank you. That's all from us.